Really tough question, trying to think about a 3D solid and what is going on inside it. How can we work out the diameter of each of these holes? Well, what we need to do is think about a cross section through like this. I'm going to try and draw that now. Okay, and then I've got actually this sphere is going to create a circle going inside, a bit like that. And then this sphere is also going to create a circle and they're going to touch because it tells you that the holes are just large enough to touch the hole in each neighboring face. And there's going to be one on the back and then one here as well. Okay, something like that where they're just touching. Right, now let's focus on just these two here. Okay, where they touch, we've got the centers of the circle, and it must be that this gives a straight line. I know it doesn't quite look like it, but whenever you have two circles that touch, there's going to be a perpendicular line here. This is called the normal, and then this line will go to the centers, and there's 90 degrees here. Um, and so that's everything. That's everything we need there. And I can actually construct a right angle triangle from this because we're interested in the diameter of each hole. So now I can look at the radius. This length is actually 2 times the radius, which is in fact the diameter. And then because the cube has sides of length 2, this must be 1 and this must be 1. So in fact, we can just use Pythagoras' theorem. Do you know what? I'm going to change 2r to the diameter because that's what I'm interested in. This suddenly becomes a very simple problem once you've got this picture, but that's obviously the challenge to be able to get it. Got a right angle triangle with a hypotenuse of d, sides of 1. So d is equal to the square root of 1 squared plus 1 squared. It's just equal to root 2.